So let's go through the simple stuff first. For instance, number 6 on page, what is this? 451. I don't even know what this formula is, but 3 capital G is equal to 5 halves.
You said 451.
451, yeah. 3G equals 5 halves hx squared. And here we're going to solve for x. Solve for x. Now these technically aren't hard because you're not really dealing with a lot of numbers. It's mostly letters and a manipulation. So if you're going to solve for x, what would you do first? Divide by. I would definitely not take the square root. Too much junk next to that x.
Is it divided by 5 halves?
Well, if you divide by 5 halves, what's that really doing?
Multiply by that too.
2/5. Do the reciprocal. Remember, multiplicative reciprocals are just, multiplicative inverses are just reciprocals. So if I multiply both sides by 2/5, that'll get rid of the 5 halves. Yeah, more. Because 2/5 times 5 halves, that'll give you 1, you know, that inverse identity thing. On the left-hand side, what's 2/5 times 3g? 6/5 g. So 6/5 g is equal to
hx squared.
hx squared.
Divide by h.
Divide both sides by h. Now here comes the funny part. Where do I put the h on the left-hand side?
On the bottom.
Yeah, but where?
Underneath the g.
Yeah, I guess you could put it underneath the g, or you could just put it with the 5. You could just put it with the 5.
Oh, okay.
But I can put it underneath the g. That'll be fine. So we get, and I'm going to just combine this as one ugly term. This is 6g over 5h is equal to x squared. And what? Square root both sides. You got a perfect square, it's isolated, square root both sides. I'm going to do a little flipping around with the equation. Put the x first, so x over here is equal to, what's the first thing I write on the other side?
Square root.
Nope. Plus or minus. So it's going to be plus or minus the square root of 6g over 5h. The book leaves it that way. What's wrong with that? It's a fraction, and a fraction is underneath the square root, and you can't have fractions under square roots technically. But with a formula, we don't know what h and g are, so it might actually simplify a little bit easier if you leave it all together on the inside. And then when it turns into numbers, do your little simplification. For instance, if h was 3 and g was, I don't know, no, make h like 12 and g like 30. This thing would simplify rather nicely, and then you just have one square root. So with formulas, don't worry about all the laws of exponents, or laws of radicals and all that fun stuff. You get a nice little expression, just leave it alone, because eventually you're just going to plug in numbers, and then you can simplify after that. So don't try to force an issue with this. In other words, don't go farther than you really, really have to. That one's kind of easy too. Number 8. 9x squared minus 2 equals 3b. Of course, we're solving for x. All right, how would you solve for x?
Add 2 out.
Add the 2 over, so we'll get 9x squared is equal to
3b plus 2.
3b plus 2. Remember, when you move things from one side to the other, it has to change sign. All right, what would you do next?
Divide by 9.
Yeah, sure, divide by 9. So divide by 9, divide by 9. You get x squared is equal to 3b plus 2, all divided by 9.
Square root.
Square root both sides. Get my cover up here. Square root the left, square root the right. The left becomes
X
x. The right becomes
plus or minus
plus or minus
square root
square root
3b plus 2.
3b plus 2
Over 3.
over 3. Remember that radical, the square root can split top to bottom. Square root of 9 is 3. Ta-da! Done. Now, of course, if x has to be positive, you can get rid of the negative. If x has to be negative, you can get rid of the positive. It really depends on what these formulas are talking about. Oh, do they get harder? Not really. Ooh, that one's good. Too bad it's number 15. Number 16. That's ugly. This is probably the worst of the solve for a variable. A equals P parentheses 1 plus R all squared. And we're going to solve for R. Anybody recognize this formula?
Yes.
What is it?
I know.
Nobody knows? Has to do with money. This is the amount of money after a certain period of time.
The principal.
This is the principal, this is your interest rate, and this means 2 years. Compound interest.
That's 140.
It's compound interest.
Oh, yeah.
Compound interest. It's usually written A equals P parentheses 1 plus R over N raised to the NT, but N in this case is equal to 1, so it's once a year, so that's 2 years. So you're trying to find the interest rate on 2 years alone, 2 years savings account, whatever. All right, what would you do first to solve for R? See, I wouldn't, but you can.
Distribute.
No, you cannot distribute P. Why can't you distribute
Why can you not distribute P?
You tell me.
Because it's great.
Which what? Because it's square.
Because it's squared.
So
Order of operations is
square.
parentheses, exponents, and then multiplication and division. You can't touch the P and drag it in. So if you want, yeah, you could divide by P. You get A over P is equal to 1 plus R all squared. Now what's the only thing you could do here?
Square.
Square it. So what's 1 plus R all squared?
1 plus 2r squared. R squared
1 plus 2R
plus r squared.
plus R squared. You have to go off to the side and go 1 plus R times 1 plus R, and then FOIL it all out. It's kind of backwards, but we'll fix that in a second. What don't you like about this equation? Fractions. That's one thing I can't stand because it's hard to work with. So what can I do with the P? Multiply through. So that's why I said you can divide it across, but it's going to come back. Also, I'm going to change the order of this so the degree is to the far left. So we're going to get A equals PR squared plus 2PR plus P, right? So there's a nice little quadratic. If you have a quadratic equation and you're trying to solve for R, up here, what do you want? What's your main goal? What's your first goal if you get lost?
Write the formula down.
Can't use the formula yet. You have to get it into a certain format. No, that's linear equations. Quadratic equations, what's the one thing you really want to get it equal to?
0.
0. So what needs to move?
The A.
That A. So we're going to get 0 over here is equal to PR squared plus 2PR plus P minus A. Okay. So if you're ever dealing with a quadratic equation and you get lost, get it equal to 0.
How come we just subtracted it out? When we usually multiply it out of there?
What are you talking about?
The A.
To get the A to the other side and get it equal to 0, you have to subtract it out. If you divide it out, you're leaving behind a 1. And you don't want it equal to 1, you want it equal to 0. So we're going to subtract it over. All right, so here's a nice little quadratic equation. How are we going to solve it? Good luck. There ain't no way you're factoring this. Can't factor it. What's the other option? It's not a perfect square, so we can't use the square root method.
You can't use the formula method.
Why not?
Because there's too many.
Really?
You only have A, B, and C. You got A, B, C, and D up there.
No, I have A, B, and C. You just have to look at it right. What letter, what variable is A usually next to? something squared, right? So A is equal to P. What is B usually left next to?
The second middle one usually.
The middle one, usually the R, right? The single factor. So 2P must be equal to
B.
B. So what's left must be C, P minus A. So it
Um,
becomes, P is just a number minus A is just a number. That'll be a single number. So you got to look at it like this, as a single number rather than as two separate ones.
But usually when we do the formula, isn't it? We just, when we see just a letter, we assume it's 1 and we plug 1 into the formula.
No. See, the variable here is R. This one has no
R.
R, so this must be
C.
the constant, which is C. Where A is equal to P and B is equal to 2P, this must be C. It's kind of a weird way of looking at it, but that's the way it is. All right, so A is here. This is A. B is right here. And C is this whole ugly expression at the very end. It's the number, just the single number not next to a variable. So what we're solving for here is R. It's going to equal negative B plus or minus the square root of B squared minus 4AC all divided by 2 times A. If you start to memorize the quadratic formula, it's better to write actually that out so you can just plug your numbers into it. All right, so B is equal to?
2P.
So 2P goes here. 2P also goes here, because it's B squared, minus 4A,
1, maybe PR.
it's P, not PR, it's just P.
Oh, okay, P.
R is your variable, that's what we're trying to solve for. And C, P minus A. That's what you said, right?
I said C for a minute.
And then 2 times A is
P.
P. So there's your quadratic formula with the solution for R. Now there's not much you can do to it. I guess you can simplify it a little bit. I'll get out my knees or something. This is R equals negative 2P plus or minus the square root of, what's 2P all squared?
2P.
It is not.
1P.
No. 2P all squared.
4P squared.
What is it?
4P
4P
squared.
squared. It's 2P times
I was
2P.
thinking square root.
I know. 4P squared. We could distribute negative 4P through the P minus A. Negative 4P times P is?
Negative 4P.
Negative 4P squared. And negative 4P times negative A
Positive 4PA.
is a positive 4PA. Or 4AP, sure. 4AP. Keep it alphabetical. All right, all over, of course, 2P. Oh, this is going to simplify rather nicely. I didn't expect this. What happens to the 4P squares? They cancel. I'm going to bring it back up here. So we're going to get R equals negative 2P plus or minus the square root of, what's left under the square root? 4AP. The rest of them, the other two, 4P squares cancel. So you get 4AP, all divided by
2P.
2P. Now there's only one last little simplification that can happen.
The 2P's cancel.
Oh gosh, not through addition and subtraction. I mean, you could separate it. You could go negative 2P over 2P plus or minus 4, the square root of 4AP over 2P. But you better, split it. But I'd rather you just worry about one thing. Square root of
Kick the 4 out. 2.
4. Square root of 4 is
2.
2. So this becomes R equals negative 2P plus or minus 2 square roots of AP, all divided by 2P. But now they all have a common factor of 2, so we can reduce it one last time. So negative P plus or minus the square root of AP, all divided by P. And there's your answer. And if you want, you could separate the P and have it as negative 1 plus or minus the square root of AP over P. Isn't that horrible? Oh my gosh, that's just nasty. Too bad you didn't write it down. Yeah. That's the worst it can do. Where you're putting quadratic formula and a bunch of letters into it.
Okay, don't erase the other.
Okay. All right. Word problems.
Oh,
I ain't got no paper.
Me neither.
Aww. You're running out? You only need a few more days' work. We're near the end.
It's time for us
this
to
is
go.
the end.
No, it is not. Not even close. Pythagorean theorem?
Oh, yay. You read my mind.
You all know what the Pythagorean theorem states word for word, right?
Yeah, sure.
Pythagorean theorem has to deal with a right triangle. And generally we label the sides A, B, and C. What is the side C called? Hypotenuse. Most people know that one. What's the side A and B called?
No.
Then everybody's like really quiet. Sides, yeah. But they actually have a specific name inside of a right triangle. The C is the hypotenuse, A and B are called legs. The legs of the right triangle. And the theorem actually states that the sum of the square of the hypotenuse is equal to, the sum of the square of the legs is equal to the square of the hypotenuse. Most people just write the formula down, and the formula for Pythagorean is this. Ooh. I read it backwards. C squared equals A squared plus B squared. Why? Well, out of all the three sides, which one's the most important? The hypotenuse. I like putting that one first. So you recognize what the hypotenuse is, you plug in any number for the hypotenuse here, and then you worry about the legs second. Because the legs, it doesn't matter if you call it A and B or B and A. They're interchangeable. But C has to be the hypotenuse. All right. So let's say this is number 24. Really doesn't matter. I can make up one. If B is equal to 5 and C is equal to 10, let's say feet, just to keep some measurements on it. And you plug it into the Pythagorean theorem, start off with the formula first, and plug in what you know. Do I know C?
Yes.
Which happens to be called the hypotenuse, and it's 10 feet. So you put in here 10 squared. Do I know A? Nope, leave it alone, A squared. Do I know B? Yeah, that's 5, but don't forget to square it. Now don't get confused between squares and square roots here. We're going to be bouncing back and forth between both of them. So you got to make sure your language is right. 10 squared is?
100.
100. It's going to equal A squared plus 25. And if you solve for A, you're going to get, well, A squared first. You're going to get A squared is equal to?
75.
75 by subtracting both sides by 25. And then how do I solve for A?
Square root.
Square root both sides. So we're going to get A is equal to
Plus or minus.
plus or minus, technically, the square root of. Now, we're talking about the side of a right triangle. Could it have a negative distance?
No.
A negative length? No. So what we're going to do is we're going to get rid of the minus part of it, and it's not because we're don't want to do it, it's just that it doesn't make any sense. So we're going to deal with the positive part, positive root only. Square root of 75. Does it break down?
5, 5, 3.
5 square roots of
5.
Oh, 5 squared is 3.
5 square roots of 3. This is 3 times 25, which is 3 times 5 times 5.
Oh, 3.
And you're going to pull out a 5 and leave behind a 3. So this is 5 square roots of 3 feet. Whatever the heck that's equal to. Do they write it as a decimal? Nope, they leave it as 5 square roots of 3. So that's pretty much all the Pythagorean theorem's about. Pretty easy. Until you do something like number 30. This should be easy too. The two sides of a tent are equal in length and meet to form a right triangle. The two sides of a tent are equal in length and meet to form a right triangle. If the width of the floor of the tent is 8 feet, what is the length of the two sides? Alright, so you have to kind of imagine that you have this tent and this is the floor. And this right here is a right angle. They meet to form a right angle. So where's the hypotenuse on this thing?
C, the bottom.
It's at the bottom. It is the floor. It's opposite the right angle. Do I know the lengths of the other two sides of this triangle? No, but so what do I call them?
Hypotenuse.
No. X and X, because they told us that these two sides are equal. So call this side X. Call this side X. Do I know anything about the floor?
Yeah, I don't know.
If the width of the floor of the tent is, oh, if you turn to the right page, you'd probably find it, is 8 feet. So we're going to use Pythagorean theorem on this. So you go c squared is equal to a squared plus b squared. And c in this case is 8. So you get 8 squared equals, what's a?
X.
X. So we get x squared here. What's b?
X.
We get x squared there. And then simplify. What do you get?
64 equals x squared plus x squared.
Which is
2
2x squared. Distributed property, all that fun stuff. You know, pull out an x squared, be fine to 1 plus 1. All right, how do you solve for x?
Square root.
What? No.
Divide
Get
by
the
2.
square by itself.
Divide by
Divide both sides by
2.
2. Get that out of the way. 64 divided by 2 is 32. It's equal to x squared. And how do you solve for x? Square root both sides, and you're going to get x is equal to, remember, we're ignoring the negative root, so we'll just talk about the positive root. It's a physical object, we can do that. Square root of 32, which is equal to, what is it? 4 square root of 2. So x is equal to 4 square root of 2. Okay, let's do this one. 36. A children's playground is triangular in shape. Its altitude is 2 yards shorter than its base. The area of the playground is 60 square yards. Find the base and altitude of the playground. All right, so the children's playground is triangular in shape. Does it tell you what kind of triangle? Don't assume it's a right triangle then. It's just some weird triangle. So draw basically a scalene triangle. Shouldn't look anything like a right triangle. Oh, mine always do. But it's supposed to be scalene. Now, when they talk about an altitude, what the heck does that mean?
The height of the middle
So where do I drop it?
from the center point down.
From the top vertex down, so we get this thing. This will be our height, our altitude. You can call it h or a, it really doesn't matter, Rich. All right, what else do we know about this? We know the area of this thing is 60 square yards. I'll put that off to the side. 60 square yards. What else do I know? The triangular in shape. Its altitude is 2 yards shorter than its base. This is the base from here to here.
B minus 2.
So what's equal to b minus 2?
The height.
The altitude is 2 yards shorter than its base. Yeah. So h in this case is going to equal b minus 2. All right. So what formula is going to put together this altitude, the base, and the area?
And
Area of a triangle, which is
1/2 base.
1/2 base times height. So we're going to go area equals 1/2 base times height, and plug in what we know. Do we know anything about the area?
6.
Yeah, it's 60. Is equal to 1/2. Do we know what the base is?
B.
It's just b, that's the base. So we'll leave that alone. What's the height?
B minus 1. And then minus 2.
B minus 2. What would you do first to solve this equation? Yeah, what would you really want to do? What don't
Get
you
rid
like
of that
about
fraction.
that fraction? That fraction. So what can I do with the fraction?
Multiply by 2.
Multiply both sides by 2. Get rid of the fraction first. And then you can distribute it and it makes it a little bit nicer. All right, so 2 times 60 is 120. If we distribute the b, we're going to get what?
B squared minus 2B.
Minus 2b. How do we solve this equation? Get it equal to 0. Move to 120. So you get 0 equals b squared minus 2b minus 120. How would you solve that?
That formula.
Would you use the formula? Would you just jump right into it? You can. I mean, negative b plus or minus squared, b squared minus 4ac. You can. But that formula sometimes can get a little bit long, and plus it has a lot of little mistakes you can make in it. If you can avoid the formula at all costs, I would highly suggest you do. There are 2 different ways you can solve this without the formula. Number 1, you could factor. But I don't want to do factoring because this chapter didn't even talk about it. So what's the other method I showed you how to solve quadratics with?
Take half of it.
What's that called?
I don't know.
Round, squaring the root,
Completing the square.
completing the square.
So I'm going to set this up as a completing the square just to practice it. So it's b squared minus 2b, leave a space, is equal to
20.
120. Positive 120 because we're going to shift it to the other side. All right. What do I take half of?
2.
Negative 2. Half of negative 2 is? Negative 1. Square it is positive 1. And we're going to add it to both sides. Okay. Let me bring it up here. So b squared minus 2b plus 1 becomes? B minus 1 all squared is equal to 121. What do I do to both sides? Square root it, so it's going to become b minus 1 is equal to plus or minus 11. Don't forget that plus or minus, we still need that. And then add the 1 across, so we're going to get b equals 1 plus or minus 11. And the 2 answers out of this are going to be 1 plus 11, 12. And the other answer is going to be 1
10.
minus 11, negative 10. So which one is it? It's got to be the 12. So the answer to this problem is 12. It's definitely not feet, yards, because our measurement up here is yards squared. So 12 feet. Now this is only the, what do we solve for here? I like that someone had it stuck in my head. Feet. This is the base. So what's the height of this thing? 10. Which is kind of weird. Yards. It's kind of weird that the other answer over here is the 10. And you'll find that this happens a lot where you're finding one of the answers is positive and the other answer is the other dimension, which is kind of weird. But don't assume that it is because I'm quite sure there's a few out there that don't work out that way. A quadratic type word problem. Page 453. Uh, 38. Benita, there we go. Benita traveled at a constant speed on a gravel road for 40 miles, then she traveled 10 miles per hour faster on a paved road for 150 miles. If she drove for 4 hours, find the car's speed for each part of the trip. So there's 2 parts of the road. Gravel, hour faster on the paved road for another 150. So this portion of the road was 40 miles. This portion of the road was 150 miles. They just want to show that changing speeds. If she drove for 4 hours, so the only thing I know about time is 4 hours. And I also know that she traveled 10 miles per hour faster on the paved road. So what is the most unknown here?
How fast she was driving on the gravel road.
How fast she was driving on the gravel. So we're going to call this X miles per hour. So how fast was she going on the paved road?
X plus 10.
X plus 10 miles per hour. Okay. So what formula associates all this information together?
The quadratic.
No. We have distance.
Oh,
We have
time plus time what? Distance.
Times rate.
Yeah, distance equals time.
Interest.
Time rate.
distance times what?
Distance
Nothing.
equals time.
Rate
Distance
times
equals rate times time.
Rate times time.
Distance equals
Double
rate
time again.
times time. Now, how many of these equations are we going to come up with?
Two.
2, because there's 2 distances, there's 2 different rates, and there's going to be 2 different times. So the first distance was 40 miles. Its rate was X miles per hour, and the time traveled is
X plus, there's just X. Oh, 40.
the time traveled.
Well, we don't know.
You don't know. So this is another one where you're going to say T1 and T2. And I know the sum of T1 plus T2 must equal
4 hours.
4 hours. So there's actually 2 unknowns in this problem. The time is one unknown, the rate is the other unknown. We're going to have to play around with this idea a little bit. Now, so we don't have to deal with 3 variables, which would be x, t1, and t2. What can I do with t1 or t2?
Add it together.
Well, I can solve for one of them. In other words, if I don't want to work with t2, I can have it in terms of t1. So t2 is equal to what?
T1 number 4.
Oh, how do you solve for t2?
You multiply T1 out, or divide T1 out. Subtract T1 out.
One of those operations,
Yeah,
you'll
one of
hit it
them.
eventually. You subtract it across. So it becomes 4 minus
T1.
t1. So this is one variable. t2 is going to represent this 4 minus t1. And the other one's going to be t1. This one's going to be the gravel. And this one is going to be the pavement. You have to get these times perfect. And I guess you could have written one as t and the other one as 4 minus t. That'd be perfectly fine too. But I find sometimes people get lost, so it's better to say my 2 times have to add up to 4, so one of my times is 4 less than the other. Or that time less than 4, bad number. So if this is the gravel, you're going to get 40 equals x times
T1.
t1 for the gravel road. And then the other one is going to be 150. Let's put a line here. 150 equals
T2 equals, 4 minus T1?
distance equals rate times time. The rate is? No, rate. Rate is not 150 miles. That's a distance. What's the rate that you drove on the pavement?
It's X plus 10.
X plus 10. Don't just throw things at this. You have to pick pieces perfectly. What is the time that they were traveling on the gravel pavement? The gravel pavement, the pavement.
100 was up, but we don't know.
Yes, we
Well,
do.
It's 4 minus T1.
4 minus T1. Now here you can get rid of the T1s and just call it T, but I'm going to leave them alone. All right, that's ugly. What can you do? What are we trying to solve for? The time or the rate? What's a bad problem asking?
We're finding the rate.
We're trying to find the rate. So we're more interested in the x than we are in t. Now you can do this 2 different ways. You can solve for the t1, get that answer, plug it back into the formula and find the rate. Or you can solve this for x directly. One's a little bit easier than the other. So if you're going to solve for the x directly, that means you're going to have to solve both of these equations for t1. Is that going to be an easy thing to do? This one's easy, divide both sides by x. This one is not so easy. You'd have to divide by this, subtract it 4, and change signs. That's a little... What about solving for x? Well, this one's easy because all you have to do is divide by t1. This one actually isn't too bad because you can divide by 4 minus t1 and then just subtract 10. So what I'm going to do is I'm going to solve both of these for x, and then I'm going to solve for time after that. Generally what happens is if you're trying to solve for an equation that has 2 variables, you solve for the variable you could care less about. And what happens is it goes away. In this case, that's not going to happen. So if I solve for x over here, you're going to get x is equal to 40 divided by t sub 1. Yeah, just leave it alone for now. If I'm going to solve for this x, it's going to be x plus 10 is equal to 150 divided by 4 minus t sub 1. Okay. And then finally subtract the 10. So we're going to get x equals 150 divided by 4 minus t sub 1 minus 10. So we get these 2 equations. Now the only thing...
Why didn't we do distribute.
Distribute.
150 equals x plus 10, 4 minus t1. I will
Oh,
distribute it and
You mean FOIL this out?
Yeah.
Ooh, because then you're mixing x's with a 4 and then an x with a t, and it just gets all... What you're trying to do is solve for x, so what you want to do is just get that piece over to the other side. Treat this like 5, and you just want to move it over to the other side. Now the fun part is these are both equal to x, so they must equal each other. So the final equation is 40 over t sub 1 must equal 150 divided by 4 minus t sub 1 minus 10. And that's the equation we need to solve. So how do we solve it? What would be the first step? Adding 10 doesn't help. The 10.
Get rid of the
We can't
fraction.
cross multiply because it's not a fraction equal a fraction.
Get rid of the fraction.
How do I get rid of the fraction?
Multiply 4 minus t sub 1 to both sides.
Just 4 minus t sub 1. Remember, these are two different numbers. 4 minus t sub 1 is different than t sub 1.
Oh, then yeah, that t sub, yeah.
So it has to be both of them.
Yeah.
So I'm going to multiply everything by t sub 1 times 4 minus t sub 1. Oh, we did this a long time ago. It's a nice little review. What happens to the t sub 1s when they hit each other?
Cancel.
They cancel. What you're left with is 40 on the top times 4 minus t sub 1. All right? What happens when the 4 minus t1 in the bottom hits t1, 4 minus t1?
Cancel.
The 4 minus t1 cancels. What are you left with?
150 t sub 1.
150 times t sub 1 minus 10 times t sub 1, 4 minus t sub 1. Nothing cancels there. Yeah. Now what? Distribute. 40 times 4?
160.
160 minus 40 t sub 1 is equal to 150 t sub 1 minus 10 t sub 1 times 4. Well, I already have a minus, so 40 t sub 1. Negative times a negative. Positive. 10 t sub 1 times t sub 1. 10 t sub 1 squared. What kind of equation is this?
Linear? No, it's not linear because you said you don't want to do it.
It's not linear because it has a square. So what kind of equation is this?
The square of the root.
No.
Root in the square.
I
Quadratic.
mean, it's a quadratic. It's a quadratic. You're just going to go through every word until you hit one. So if this is a quadratic, what do I need to do?
Send a 0.
Get it equal to 0. So we're going to bring the 40 t sub 1 and the 160 across. Combine these two. That's what, 110 t sub 1? So we'll get 0 is equal to 110 plus 40. Oh, wait a minute. The 40s are just going to cancel. So we're just left with 150. I'm going to put this one first. 10 t sub 1 squared plus 150 t sub 1 that's 164. Just make sure you're awake and not texting. All right, what's one thing I could do to this whole equation?
Don't do it.
No. Just the equation, not the problem. Divide by 10. It'll make our life a little bit easier. T sub 1 squared plus 15 t sub 1 minus 16. Okay. How do you want to solve this equation? Quadratic formula?
Yeah.
No. You can complete the square, but the middle term's odd, and I'd rather not deal with an odd middle term. What's one thing you could do to a quadratic sometimes? Factor. Are there factors of 16 that subtract up to 15?
16 and 1.
16 and 1. So this is going to factor into t sub 1, 16 and 1. What kind of 16, what kind of 1?
Positive 16, negative 1.
So this becomes 0 equals, not 0 equals. T sub 1 equals negative 16. T sub 1 also could equal positive 1. Well, which one has to be the answer? The positive one, because the negative one makes no sense. Negative 16 hours in the past. So, since there's no such thing as time travel so far yet, we're going to choose the one. What does that one represent? $1, 1 mile,
1 hour.
1 hour. Because it is talking about time, and we're talking about miles per hour, so it's 1 hour. So now we can figure out how fast we've been going. Since t sub 1 is equal to 1 hour, x here is going to equal 40 miles per hour. X represents what? The speed of the car on
The gravel road.
the gravel road. So this is on gravel. And if he's going 10 miles per hour faster on the pavement, he's doing how fast? 50 miles per hour.
I told you, he was hauling ass on that gravel road.
It's not that fast. And this is the pave. And that's the answer to the problem.